Hello students, welcome back. Let's continue to discuss atmospheric refraction. What is atmospheric refraction? The refraction of light by Earth's atmosphere is known as atmospheric refraction. And one of the application of atmospheric refraction is twinkling of stars. Let's discuss about twinkling of stars caused due to atmospheric refraction. The light rays coming from the star reaches our eye after passing through many different layers of atmosphere. Due to changing refractive index in the atmosphere, the light rays undergo continuous refraction. As stars are point-sized sources of light, so even the slight variation in the path of light leads to fluctuation in the position of the stars, and it appears to twinkle at night. Our next phenomenon due to atmospheric refraction is duration of sun's visibility, that is early sunrise and delayed sunset. Sun is visible to us 2 minutes before the actual sunrise, and even though the sun is just below the horizon, we can still see the sun. Similarly, sun is visible 2 minutes after the actual sunset. So what is this horizon? It is the line at which Earth's surface and the sky appears to meet. Horizon is best visible when we are looking at sea or ocean. Imagine you're standing on Earth and you're looking at the sunrise. If there was no atmosphere, we could see the sun only after it came up the horizon. But the layers of atmosphere causes refraction of light. This manner, the light bends towards us and reaches our eyes. This way, we can see the sun before actual sunrise. Similarly, due to atmospheric refraction, we can see the sun even after 2 minutes of sunset. Now, let's discuss scattering of light. When sunlight falls on a mixture of minute particles like smoke, tiny water droplets, dust, it gets scattered in all the direction. This phenomenon is known as scattering of light. Our next topic would be Tyndall effect. The phenomenon of scattering of light by colloidal particles gives rise to Tyndall effect. This phenomenon is seen when a fine beam of sunlight enters a smoke-filled room through a small hole. Thus, scattering of light makes the particle visible. Intensity of the scattered light varies inversely to the fourth power of wavelength of the incident light. That is, I is proportional to 1 by lambda to the power 4. Two main applications of Tyndall effect or scattering of light is blue color of the sky and reddish color of the sky during sunrise and sunset. Now let's discuss first, why does the sky appear blue? When sunlight passes through the fine particles in the atmosphere, they scatter blue color more than red. Wavelength of blue is less than that of red. Therefore, blue is scattered the most and sky appears blue. Now, talking about the reddish color of sky at sunrise and sunset. Imagine you're standing on Earth and looking at a beautiful sunset. During sunset, sun is near the horizon and the sun rays have to travel the longest distance to reach us. Since sunlight has to travel such a long distance, a lot of scattering will happen. Sunlight or white light is made up of 7 colors. In those 7 colors, blue having minimum wavelength gets scattered the most and no blue light reaches our eyes. Whereas red light having the largest wavelength reaches our eye because it is least scattered, and that is the reason why the sky appears to be reddish during sunrise or sunset.